They tell us that something's bisected. So you may be looking, or maybe you want to pause the video and look for what type of reasoning you could use. But there's only two of them that talk about bisects. You have definition of an angle bisector and definition of a segment bisector, which we don't have angles being bisected here. So in this case, we're going to use definition of a segment bisector. When we're looking, it's something we sometimes get caught up on, because which one is actually being bisected? Well, it's segment CD that's being bisected. So I actually already have in my picture labeled C, M, and MD, those measures the same. And that's usually it. However, here it says they bisect each other. So you might have noticed I labeled both sets of segments. And that's not always going to be true when we have something being bisected. But here we have both being bisected because they bisect each other. So I'm actually going to be able to say by definition that those measures, the measure of CM and the measure of MD, are going to be equal, along with the measure of AM and the measure of MB. And again, often the theorem will say congruent. By definition, we'll be able to say the measures are equal. And we have a couple of equations. Can you replace anything there? Well, no. CM, MD, AM, MB, those are all different. However, they did give us something else besides just the bisect. So we use that first part of our given. What about that second part? Then we could maybe replace. But remember, according to the conditions of the replacement rule, A has to be equal to B. So the measure of A has to equal the measure of B. And right now I have congruency with that statement in the given. So I'm going to go ahead and change that to the measures being equal. Definition of congruent segments. Remember, to be congruent means all the measures, anything that can be measured, is the same. Well, then the segments are congruent. Their measure, because that can be measured, the length is the same. We can say that because that's what congruency is. Definition of congruent segments. And now I actually have three equations, so certainly it seems like I should be able to replace something. And what you choose to replace first is going to make a difference how long this proof takes or how many more steps it is. But if you're not sure, you can just try. If you just want to try substituting into the first one, if you just want to try substituting in the last one, it's up to you. I'm kind of looking, and maybe you want to pause and think which one would be quicker, but I'm looking and saying, if I use the third one, I can actually replace both. I have something that equals CM. I also know something else that equals MB. So I'm going to pick the third one and replace both of them. Replace CM with the measure of MD. That's where they set up in that first one. And then MB, that measure, according to the second equation we said, equals AM. So I'm going to replace that measure with AM. Replacement rule. And that is really close to what I wanted to try to prove. But I have a couple things I need to just change here. This is a formal proof, so we need to be very formal about stating exactly what they've asked us to state. So if we have MD and AM, well, they had AM and MD. We got to switch the order. We also need to change the congruence, and it doesn't matter which order you do it in. If you want to use S little y p e, we need to do the switch the order now because that would be a property of equality. If you wait to switch the order, you'd end up using S little y p c because you'll end up with congruency. But I think I'll switch the order first. So what I'm going to do is I'm going to change this order here. The measure of AM equals the measure of MD. That's symmetric property of equality. And then I'm going to change back to congruence, kind of like I did at the beginning, because with a segment, there's only one measure. And to show something's congruent, you need to show all the measures. Well, that means if there's only one measure, you only have to show the one that is the same. And that's enough to say that they'd be congruent. Definition of congruent segments. That's what it means to be congruent. Can make that conclusion.